Welcome back to this series, and this is a question 10 part A, and it's a trig identity. It's quite a tough question if I'm gonna be honest. So here we're using 1 minus cosine 2 theta is 1 minus 2 sine squared theta. So we plug this into our formula, and we're gonna see that the 1's cancel out on the top. But here I make a mistake that just shows how one substitution might not work for the whole question. So we're going to have to use another form of cosine 2 theta for the denominator, and you'll see this in a minute. And I've left this in the video just so it's informative. Like, it's okay to make mistakes, and it's just as long as you realise your mistakes. And so here I'm thinking this is all fine, so I use the sine 2 identity, which is 2 sine theta cosine theta. And then on the top we simplify to 2 sine squared theta plus 2 sine theta cosine theta using the sine double angle formula. And then on the bottom I've expanded these brackets wrong, and this is where I noticed a mistake, because I've factored out on the top the sine theta, and then I've noticed that on the bottom I'm not going to get this sine theta plus cosine theta in the denominator. So this is where in my brain it's like, oh, so I've made a mistake. So I relook at the question and I realise we can use the alternate form of the cosine double angle formula, which is 2 cosine squared minus 1. And so obviously I've noticed that now, and I've switched pen, and I'm just writing that 1 minus 2 sine squared theta is equal to 2 cosine squared minus 1. If you use sine squared plus cosine squared is equal to 1. So then using this formula, the expression becomes a lot nicer. So we get on the numerator, we get 2 sine squared theta plus 2 sine theta cosine theta, all divided by 2 cos squared theta plus 2 sine theta cosine theta, which then obviously simplifies down. If we factor out a sine on the top, we get 2 sine theta, lots of sine theta plus cosine theta. And then if we factor out a 2 cosine theta on the bottom, we get cosine theta plus sine theta, which is the same thing. So then we can cancel out these two on the top and the bottom, which then gives us sine theta over cosine theta, which we just know is tan theta, and so we've proved the identity. Thanks for watching.